As you know that myself Akash in front of you. So today our lecture presentation on the topic organic chemistry basics and nomenclature. Okay, so then first I will tell you what is difference between organic and inorganic compounds. Inorganic mean the living things, and organic inorganic mean non-living things, and organic mean living things. And so first I will tell that what is introduce the organic chemistry. That what is organic chemistry? Organic chemistry is a chemistry which deals with the study of hydrocarbons and the derivatives known as organic chemistry. First I will tell the introduce who gave the theory of organic chemistry. The first the scientist name is Berzelius in 1815. He gave the theory that he only said that the organic compounds we only get from the not only living things, for example from the tissues of the plants, from tissues of animals. But the scientist name is Friedrich Wohler in 1822-28, and he's opposing on this point. That he says that we can get the we can convert the inorganic into organic. So the inorganic compound is ammonium cyanide, and its formula is NH NH4OCN. So it is a formula of ammonium cyanide, so it's converted into the urea. Okay, so then it is an ancient history of the organic chemistry. And so then I'll tell you the characteristics of the organic chemistry. Okay, so first I'll tell you what the source is, and the composition is solubility, melting and boiling, and then fifth number is rate of reactivity and combustion in the stability. Okay, the first is source. How can you obtain the organic chemistry? So first I tell that we obtain from organic chemistry organic compounds from the minerals, from the plants, from the tissues of the animals. So this is a source of organic compounds. So then the second one is composition. How the organic compounds is made up of organic compounds. The key element, the main important element is the carbon. So actually carbon is the main important compound. So then another is hydrogen, then and nitrogen, phosphorus. So these are the compounds that we make the organic compound. So then the solubility. So have you listened this like dissolve like mean that mean if something is polar, then we can dissolve in the polar. If something is in polar, we can dissolve in the in polar. So this is a famous quotation that like dissolve like. So then the melting and boiling point. So its melting and boiling point is bit less because they have a covalent bond, but it's so weaker. So that's why it's soluble. Its melting and boiling point is weaker. So rate of reactivity, they have a less reactivity, mean that but some conditions they have a rate of reactivity is less. Okay, so then the combustion. That everything is burning with the presence of oxygens. For example, that is, so it is in this organic chemistry that the things is burning with the presence of oxygens. So then the stability, so they have a less stable. So then the representations, how can we write the organic compounds? So these are the four types that we can write in this through this representation of this. The first is molecular structure, condense formula, and cross and dot. So another we can say that it's electronic formula. So then the first is molecular formula. So what is molecular formula? Molecular formula is a formula that shows the exact number, and so it shows the actual number. So for example, that I will tell you the methane. Its exact number is CH4. Okay, so then another I will tell you C and the butane. What is the formula? What is the molecular formula of butane for C4 10 H10? So this is the exact number. It shows the exact number. So then moves on another thing, the structure formula. Structure formula that is shown by the single. So then structure formula, it is written in the single line, it is written in the double line, it is written in the triple line. Okay, so anybody tell how can we write the structure formula? Here Mr. Anil, he wants to write the structure formula of the butane. Okay sir, write this one.
Butane have 4 carbons and they have linkage with hydrogens, 10 hydrogens. This is a structural formula of butane.
Okay, thank you, Mr. Anil. So this is right that so then another is the condense. So condense formula that we only omitted the carb of the carbon. For example, I want to show there. So here is the CH3, CH2, CH2, CH3. So this is a condensed formula that we can write in this through this. So then cross and dot formula. So there's no difference between the cross and the structure formula. That here we use the in structure formula. Here we use the line, single line, and in this we use only cross and the dot. So the symbol is cross. So this is the symbol of cross and dot. So here we only put this one in this on the cross and the dot. So this is known as the cross and dot formula. Okay, so then the nomenclature. Okay, so nomenclature, so I'm tell you that the naming of alkane, you know that alkane, it is a saturated. First I'm tell you what is difference between saturated and unsaturated. Saturated compounds, it only have a single line. Okay, so then the unsaturated carbons, the saturated is alkane. So here is alkane is a saturated. So then another unsaturated, they have a double and triple. They both have they both line. So for example, there are two elements. So two alkane, alkene and alkyne, they are unsaturated. Okay, so its formula alkane, its formula is general formula is CnH2n plus 2. So this is the formula of alkane. So then the alkene, its formula is CnH2n, it's a formula. So then alkyne, its formula is CnH2n minus 2. So so this is the formula of the alkyne. So then was it? Okay, so then I'm telling you the functional group. So here is here I'm showing the 5 functional group. Here is alkane, its formula is CnH2n plus 2 here, and in functional group we can show in the single line. Okay, so and alkane, its functional group is CnH2n. So it is a functional group of alkene. It is shown in the double line. Okay, so then the alkyne, it is shown in the its functional group is CnH2n minus 2. Okay, it is shown in the triple line. Okay, then I'll tell you the aldehyde. So its functional group is radical carbon hydrogen double bond oxygen. So it is a functional group, and here we put on the one radicals, and then the ketone, its functional group is radical carbon double bond oxygen. So here is a so in this we put the two radicals. So the total my presentation topic is over. So thank you so much.